The next problem I'd like to look at is number 36. So, again, ignoring those two for now, I'm really trying to figure out what this integral equals, but keep in mind that there might be a problem. So this is actually 1 over x minus 2 into x plus 1, and that is a over x minus 2 from section 7.4, b over x plus 1, and just like we mentioned in that section, if you clear the denominators, and if I let x equal negative 1 and x equal 2, pretty much I'm done. If I let x equal negative 1, that's a 0. I'll get 1 equal b times negative 3. That means b is negative 1/3. And if I let x equal 2, that means 1 equal a times 3, and that's a 0. So a equal 1/3. So there it is. Pretty much this is natural log of absolute value of x minus 2 minus natural log of x plus 1. They're both 1/3. I'll take a 1/3 out of both of those. You could leave it in there. It doesn't really make much of a difference. But now when I glance at this, I say, wait a minute. I'm looking at the interval from 0 to 4. I have a problem with negative 1, which is not in there, but I have a problem with 2. So I'm going to really think of this as the integral from 0 to 2 plus the integral from 2 to 0 of dx over x squared minus x minus 2. Now either way I have to integrate. So if I take this portion first, I'm going to say I'm going to evaluate this limit from 0 to t. I'm going to take the limit as t approaches 2, and notice I can only approach 2 in this case from the left. And that would be the limit as t approaches 2 from the left of 1/3 into natural log of absolute value of t minus 2 minus natural log of t plus 1 minus natural log of 2 minus natural log of 1. So we know that this is a 0, that's a constant. Here, I'm taking the limit as t approaches 2 from the left. That would be the limit as t approaches 2 from the left of the 1/3 of natural log of t minus 2 minus, this is natural log of 2. I could just plug that in. Minus natural log of 2. This is a number. That doesn't matter. This part. If you remember, we did this graph before, and I know you were whining a bit about graphing, but natural log of t minus 2 is shifted to the right 2 units, and it looks like that. This is y equal natural log of t minus 2. And we mentioned when you put an absolute value around the argument, it reflects the graph. So whether I'm approaching this from the right or the left, guess what you're going to approach either way. This is going to approach negative infinity. So I end up with negative infinity, and therefore this will diverge. It doesn't matter whether this piece converge or diverge. If I have two integrals and I'm adding them up, if one of them is infinity or negative infinity, adding anything to it is not going to change the fact that will still be convergent or divergent. Now, I want to do one more of these types, and I'm choosing number 12, the last case scenario. What happens when you have negative infinity to positive infinity? Well, it's kind of like what we just did. What you're going to end up doing, you're going to end up saying, you know what, I'm going to integrate from negative infinity to 0. Now, I'm not going to stress out how important is it on this 0. It could be any number, but it should be on this graph, and 0 is an easy target. And 0 to infinity of y cubed minus 3y squared dy. And let me elaborate really quick again on this. The idea is, or the analogy is, I'll figure this piece out. If that diverge, I'm done. This wouldn't make a difference. If this converge, I would still have to figure out whether this converge or diverge. For this to converge, I need both of those to converge, both of them. So if I take that first one and I integrate, well, I'll notice this is y to the 4th over 4 minus y cubed evaluated from t to 0, taking the limit as t approaches infinity, negative. That's the limit as t approaches negative infinity of 0 minus 0, we got that, minus t to the 4th over 4 minus t cubed. So basically this turns out to be negative. That's going to be positive infinity minus a negative infinity, that's going to be plus infinity. So the answer will be negative infinity. Therefore, this will diverge. I don't need to do this second piece. And in case you're wondering how am I playing with infinities like that, well, after section 6.8, which is indeterminate forms, now we can play with infinity like that. That's not a problem. Now there is another portion of this section that deals with comparison and 1 over p. I'm going to save that. It's really this part. It's this integral right here. I'm going to save that until we get to the last chapter 11, and I'll talk more about that in there. For now, this is where we're going to stop. Oh boy. Okay, third time will be a charm. There it is. Let me list the homework and update that. There's the list of the homework, and I'll upload the PDF as well in the notes. You could get both.